Hello friends, how are you? Welcome to the Japan Study Center. Today we are going to see the chapter of geography, and what is our topic today?
Humidity and precipitation. There is a most important chapter. The important point here of first, water vapor in the atmosphere. There is a most important topic, water vapor in the atmosphere. You know that water vapor is a highly variable component of the atmosphere, and it is a proportion to the various form of 0 to the 4% by the volume of the atmosphere. Water can be exist in the air in all the three states of the matter. The solid, there are ice crystal, liquid, droplet of water, and gaseous is the water vapor. There is the most important three state here: the solid, the gases, and the liquid. There is the most important here form. The most commonly water exists in the air as a tasteless, colorless, and transparent is a gas known as the water vapor. You know that what is a water vapor? The most commonly water exit in the air is a tasteless, colorless, and transparent is a gas the known as the water vapor. The presence of the water in the atmosphere had made a life possible on the earth. There is a most important presence of water in the atmosphere has made life possible on the earth. Let us examine to the significance for life on the earth. There is a most important point here. We have a noted that in the lessons 10, water vapor is their atmosphere is absorbed in the significant potential of the both incoming solar energy and outgoing earth radiation. In this way, it is a present of great loss of the heat from to earth as a surface and help to the maintenance of suitable temperature on the earth. There is an important point here. I repeat again, we have noted that the lesson 10, that is a water vapor is atmosphere absorbed the significant potential of the both incoming solar energy and outgoing earth radiation. That is the most important here and the balance. And second point, the amount of water vapor present in the air affect the rate of the evaporation. There is the most important here, amount of water is a vapor present in the air affect the rate of the evaporation. There is important. And third point is also here important. The amount of water vapor present in a volume of air decided there is a quality of the latent heat or the energy stored in there is a producing atmospheric change. There is important the amount of water vapor present in a volume of air decided there is a quality of the latent heat or energy stored in it from a producing atmospheric change. The next fourth air, the amount of water vapor present in the air of the place or in a regions indicate their potential capacity of the water air from a precipitation. That is important. The amount of water vapor present in the air also affect to the standing crops favorably is on their other hand to the hot dry winds and damage to standing crop as in the case of rabi crop of north west India. That is important. And the sixth point here, the air poor in there is a water vapor continent make our body skin dry and the rough. There is important here, sixth point, air poor in the water vapor content to make our body to skin dry to the rough, and it is because of this fact that we use a cream to protect our face from a dry air of cold winter to hot summer. That is important. The most important fact here, the water vapor present in the atmosphere absorb of radiation, control the rate of evaporation, release the latent heat from the weather change, and decided their potentiality for the precipitation and effect to standing crop and the our body skin energy is of the great significance. That is important here. The next topic is the humidity. Humidity is the most important here. How does the water changing into the water vapor? There is an important question here. The heat energy radiated from to the sun change water into the water vapor, and this invisible water vapor present in a gaseous form in the atmosphere at the any time and place in the term is a humidity. In other words, we can say that their term humidity refer to the amount of the water vapor present in a given air. It indicates their degrees of the dampness or the wetness of the air. That is important, dampness and wetness of the air. Humidity of the air is mainly expressed in the following two ways. There is the most important two way here. The first here, absolute humidity and relative humidity. There is the most two important humidity here. The first here, absolute humidity. Absolute humidity is the ratio of the mass of water vapor, and actually in their air is to a unit mass of the air including the water vapor. It is expressed in a gram per a cubic meter of air. For example, if the absolute humidity air is a 10 gram, it means that 1 a cubic meter of that air hold of 10 grams of moisture in form of water vapor. Absolute humidity is a variable and change from place to place and with the change in the time. That is important for absolute humidity here. The ability of the on air to be hold of water vapor depend about entirely on their temperature. The capacity of the holding water vapor of on air increase with the increasing in the temperature. For example, at a 10 Celsius, 1 cubic meter on air is can be hold of 11.4 gram of water vapor. It is the temperature of the same air increasing to the 21 Celsius. The same volume of the air can be hold 22.2 grams of water vapor. That is the most important and understanding here the figure the next and show the relationship between to the temperature and the maximum amount of water vapor that an air can be held at the given temperature. A cursory glance at there is a figure indicate how do the water holding capacity of the air increase with increasing in the temperature. Change in the temperature and pressure condition of on air result in the change of its volume and consequently there is a change in their absolute humidity. That is important. Hence there is a need of the some more reliable measuring of humidity. That is the most important here and the next here diagram. In this figure, show the maximum absolute humidity for the wide range of temperature. You know that there is show the minus 40 Celsius is a 0 degree. That is important here, and there is a increasing to the time, and the at least is a gram per second. There is the most important maximum absolute humidity and the wide range temperature on this figure. The next here, relative humidity. There is the most important point, relative humidity. Relative humidity is the most important and reliable measure of the atmospheric moisture. It is the ratio of the amount of water vapor actually in a volume occupied by their air to be amount of the space could be contained at a saturation. There is important relative humidity here. Here show the most important here formula relative humidity here. The formula is the relative humidity is equal to the vapor pressure in the air and saturation vapor pressure is the most important here. From the figure 12.1 it is a quite a clear that air can be held a defined maximum quantity of the water vapor at the given temperature. And when this situation is attained by BS that air is fully saturated. The temperature at which a given sample of the air become fully saturated is called the depth point or the saturated point. The relative humidity of on the air at the saturation point is 100%. Since the concept of relative humidity is very important in understanding this lesson, let us illustrate it is with the help of the example that is important. The example here it is a clear in the figure 12.2 that is the air can be held up 22.2 per gram of water vapor at there 21 Celsius temperature. If this air is holding to the 11.1 grams of water vapor at the same temperature is 21 Celsius. The relative humidity of the air is will be 11.1 is upon 22.2x into 100 or the 50%. The 50% is the most important here. And if there is same air is actually holding a 22.2 grams of water vapor at 21 Celsius. The relative humidity of air will be 22.2 upon 22.2 into 100 or 100%. The air becomes saturated when it is a relative humidity is a percent is the more important here. If the relative humidity of the air is less than 100%, the air is said to be unsaturated. That is important here. The air becomes saturated. It is a relative humidity is of a percent, and the relative humidity is increasing. Then the temperature of the air goes to the down or when to the more moisture air is added to it. The relative humidity is decreases when there is a temperature of the air increasing or when to less moisture air is added to it. That is important here. In order to make it clear that relative humidity is a better measurement of water vapor in the atmosphere than the absolute humidity, yet another example can be cited to the suppose there is a tumbler is a containing is a 250 grams of water. One cannot be tell how much a portion of the tumbler is filled with there is water till one known it is a maximum water containing capacity. When one is come to know that is a tumbler can be contained to the maximum of 500 grams of water, one can immediately tell that is a tumbler it is a half filled with the water. Likewise, if one measuring a relative humidity of on the air, one not we only need to be now about it is actually water vapor content, but also it is a total capacity to the content to the water vapor at that temperature. So now you can be understand why the relative humidity is a more is a useful in making to the predictions about the atmospheric condition. That is important here. Here the most important point here arrive the absolute humidity is the actually amount of water vapor present in the gram per cubic meters of a given air, and the relative humidity is that ratio of the actually water vapor content to their maximum moisture holding capacity of on the air at the given temperature, and it is expressed is the percentage the RH is equal to the A dot H is the maximum capacity into 100. That is important here. The temperature at which a given sample of the air become a fully saturated is called dew point or saturation point. That is important here. The next point here, evaporation. That is the most important here, evaporation. The evaporation is the process of which water change from its liquid state to gaseous form. You know that? What is evaporation? Evaporation is a process which the water changes from its liquid state to gaseous form. And this process takes place at all place, at all time and all temperature. Except at the dew point or when their air is saturated. The rate of evaporation is affected by several factors. The important among them are as under some point here. The first point, accessibility of water bodies. The accessibility of water bodies here. The rate of evaporation is high over to ocean than on the continent. That is according to the accessibility of water body. And next here, temperature. The temperature is also important here. We know that hot air hold more moisture than the cold air. The hot air hold more moisture than cold air. So when the temperature of an air is high, it is capable of holding more moisture in its body. Then at a low temperature, it is because of this that is the rate of the evaporation is more in a summer than the winter. The important point here, the moisture more hold on the is a hot air, not a cold air. There is a moisture is the most important, and evaporation is more in the summer than to winter. And that is why wet is a cloth dry faster in a summer than winter. That is the most important question here. Answer here. What is why wet is cloth dry faster in summer than to the winter? The next point here, air moisture. The air moisture is here. If the relative humidity of a sample of air is high, it is capable of holding less moisture. On the other hand, if the relative humidity is less, it can be take more moisture. Hence, the rate of evaporation will be high. The humidity or dryness of the air also increase the rate of evaporation. During a raining day, wet clothes take more time to dry owing to be high percentage of moisture contained in the air than on dry days. That is important here. I repeat again,
The rate of evaporation will be high. Aridity or dryness of the air also increase the rate of evaporation. During the rainy day, wet clothes take a more time to dry owing to be the high percentage of moisture content in the air than a dry day. That is important. And next here, the winds. The wind is the most important here. Wind also affect the rate of evaporation. If there is a no winds, the air which overlies or water surface will be get saturated through the evaporation, and this evaporation will be is once saturation point is reached. However, if there is a wind, it will be a below that is a saturated or the nearly saturated air away from to the evaporating surface, and the replace it is with the air of the lower humidity, and this allow to the evaporation to continue as the long as the winds is a keep blowing saturated air away and wearing dry air. There is the most important air here. And the next here is the cloud. The cloud is over. The cloud over is the most important here. The cloud over prevent solar radiation and thus the influence the air temperature at a place. And this way it is directly control the process of evaporation. It is interesting to be note that about a 600 calorie of heat used for the converting to each gram of water into the water vapor. A calories is a unit of heat energy spent to the rising a temperature of 1 gram of water by 10 Celsius. The heat energy used for changing their state of water or body from a liquid to gaseous state, or from solid ice to the liquid water, and the state without changing its temperature is called latent heat. You know that there is the most important airline. The heat energy used for changing the state of water or a body from liquid to gaseous state, from to the solid ice to the liquid water. A state without changing its temperature is called latent heat. It is a sort of hidden heat. The hidden heat is the most important here. It is also called to the latent heat or hidden heat. The effect of which is not to be seen on there is a thermometer. The latent heat is a consumed, it is changing water into the gases from is a release when to the water vapor change into the water or ice. The release of latent heat is the air is on the important source of energy from causing a change in a weather. There is an important here. The release of latent heat is the air is on important source of energy from a causing of change in a weather. A special case of evaporation is a transpirations, and which entails is a loss of water from a leaf and stem tissue of growing vegetation. The combined loss of moisture by the evaporation and transpiration from a given area or term is called evapotranspiration. Evapotranspiration. That is the most important here. And the next here, at some point, according to this here point, the first point here, the evaporation is the process of changing water into the vapor. You know that the evaporation is a process of changing water into water vapor. The second here, important. The rate of evaporation is affected by the availability of water, temperature, and aridity of air, wind, and cloud over. That is important here. And also the third point is the most important. The heat energy used to change the state of water or body from liquid to the gaseous state, from its solid to liquid state without changing in a temperature is called latent heat. I repeat again. The heat energy used for changing the state of water or body from liquid to the gaseous state or from liquid to liquid state without changing its temperature is called latent heat. The next topic is here condensations. There is the most important here condensation. The condensation is the process by which the atmospheric water vapor change. Condensation is the process by which the atmospheric water vapor changes into water or ice crystal. There is important change into the water or ice crystal. It is just reserve of the process of evaporation, and when the temperature of saturated air fall below the dew point, the air cannot be hold the amount of humidity when it was the holding earlier at the higher temperature. This extra amount of humidity changes into the water droplet or crystal or bus depending upon the temperature at which the condensations take place. I repeat again, it is just a reverse of the process of evaporation when the temperature of saturated air falls below the dew point. The air cannot be hold the amount of humidity which it was the holding earlier at the higher temperature. This extra amount of humidity changes into the water droplet or crystal of ice depending upon the temperature at which the condensation take place. There is a most important. And the next point here, process of condensation. There is a most important point here, process of condensation. The temperature of the air fall into the two way. Firstly, cooling occur around the very small particles of free floating air when it is come in the contact with some colder object. You know that the first point here, cooling to occur around a very small particle of freely floating air when it is come in the contact with some colder object. And the second point here, loss in air temperature take place on the massive scale due to rising of air to hold higher altitude. There is important here point. Second here, loss in air temperature take place on a massive scale due to rising of air to higher altitudes. The condensation take place around the smoke, salt and dust particle which attract water vapor to the condense around them. They are called hydroscopic nuclei. That is important here. The condensation takes place around their smoke, salt and dust particle which attract to the water vapor to the condense around them, and they are called to the hygroscopic nuclei. When the relative humidity of on air is high, when the relative humidity of on air is high, a slight cooling is required to bring the temperature down below the dew point. That is important, below the dew point. But when the relative humidity is low and the temperature of the air is high, when the relative humidity is low and the temperature of the air high, a lot of cooling of the air will be necessary to bring the temperature down below the dew point, and thus condensation is directly related to the relative humidity and the rate of cooling. There is an important point here, but important here box a 2 point here the conclusion. The first here, condensation is a process of changing water vapor into the teeny droplet of water or ice crystal. There is important here, condensation is the process of changing water vapor into the tiny droplet of water or ice crystal. And the second point here, condensation takes place when the temperature of air fall below the dew point and is controlled by the relative humidity of the air and rate of cooling. There is an important point. I repeat again. Condensation takes place when the temperature of air falls below the dew point and controlled by the relative humidity of the air and rate of cooling. And the next point here, the point B. The point B is the most important here from a condensation. You know that from the condensation here, condensation takes place in two situation. Firstly, when the dew point is below the freezing point or below the 0 Celsius. You understand? The first here, when the dew point is below the freezing point or below the 0 Celsius, and secondly, when it is above freezing point, when it is above freezing point. In this way, the form of condensation may be classified into two groups. Here, from the condensation may be classified into two groups. First here, first snow and some cloud are formed when the dew point is below freezing point. The first and snow and some cloud are formed when the dew point is below the freezing point. And second here, dew, mist, fog, smoke and some cloud are formed when the dew point is above freezing point. There is a 2 point is the most important here. The form of condensation may be also be classified on the basis of place where it is occurring. For example, on the ground are nature objects such as grass blades and leaves of the plant or trees. In the air close to the earth as a surface or at the some height in the troposphere is an important point here. And the next here, first point, dew. The dew is the most important here. When the atmospheric moisture is a condensate that is deposited in the form of water droplets on the cooler surface of solid objects such as a grass, blades, leaves of plant and tree and the stone. It is a term as a dew. You understand? What is a dew? The condensation of dew from occur when there is a clear sky, little or no winds, high relative humidity and cold long night. This is important here. The condensation of dew from occur when there is a clear sky, little or no winds, high relative humidity and cold long night. And these conditions is lead to the great terrestrial radiation and solid object become cold enough to varying the temperature of air down below dew point. In this process, the extra moisture of the air get a deposit on this object. Dew is formed when the dew point is above freezing point. The dew formation can be seen if their water is poured into a glass from the bottle keep in a refrigerator. Repeat, dew formation can be seen if the water is poured into the glass from a bottle keep in the refrigerator. The water cold surface of the glass bearing the temperature of the air is in contact with the surface down below the dew point and extra moisture get a deposit on the outer wall of the glass. You know that there is a most important experiment here. The outer cold surface of the glass bearing the temperature of air in a contact. The air contact with the surface down below the dew point of extra moisture get a deposit on the outer wall of the glass. And the next here, frost. When the dew point is below the freezing point under above mentioned condition, the condensation of extra moisture take place in the form of every minute and particle of ice crystal. It is called frost. I repeat again, frost when the dew point is below the freezing point. Dew point is below to the freezing point under above mentioned condition. The condensation of the extra moisture take place in the form of the every minutes. The particle of ice crystal is called frost. In this process, the air moisture condenses directly in form of the tiny crystal of ice. And this form of condensation is a distresses from a standing crop such as a potato, pea, pulses, gram, etc. It is also create a problem from a road transport system. It is also create a problems from a road transport system. And the next year, mist and fog. Mist and fog. When the condensations take place in the air near the earth as a surface in the form of teeny droplet of water hanging and floating in the air. It's called mist. What is a mist? When the condensations take place in the air near the earth as a surface in the form of teeny droplet of water hanging and floating in the air, it's called mist. In a mist, visibility in the more than 1 kilometer and less than 2 kilometer. The mist is a visibility of more than 1 kilometer and less than 2 kilometer. But then the visibility is reduced to less than 1 kilometer. It's called fog. You know that? What is a fog? When the visibility is reduced to less than 1 kilometer, it's called fog. The ideal conditions from the formation of the mist and the fog are clear sky, calm and cold winter nights. The next year, smog. Smog is the fog that has been too polluted and discolored by smoke, dust, carbon dioxide, sulfur dioxide and other fumes. Smog frequently occur in the large cities and industry centers. It is a cause of respiratory illness. I repeat again, smog. Smog is a fog that has been polluted and discolored by the smoke, dust, carbon dioxide, sulfur dioxide and other fumes. Smog frequently occur in the large cities and industrial centers. It is a case of respiratory illness. And the next point here, fifth, a cloud. The cloud is important here. Cloud are a visible aggregate of water droplet. The cloud are visible aggregate of water droplet. Ice particles are mixture of both along with the varying amount of dust particle. A tropical cloud contains a million of droplets having to the diameter on the r per is a 0.060, 0.012, 0.02 mm. Is a very tiny particle here. Yet the liquid is a solid water amount account for the less than 10 parts per million of the cloud volume. The important here, yet liquid are a solid water count for less than 10 parts per million of the cloud volumes. The clouds are generally classified on the basis of their general form or appearance and attitude. Combining both these characteristics, cloud may be grouped as under. The next here, low cloud. The base level of low cloud varies from very near the ground to about 2000 meter. The basis type of this family is the stratus. A low and informal layer is resembling fog but not resting on the ground. The low cloud is the most important here. The base level of low cloud varies from very near the ground to about 2000 meter. The basis type of this family is a stratus. A low, informally layer is resembling fog but not resting on the ground. Stratocumulus cloud from a low, grainy layer is composed of globular marks or rolls which are usually arranged in a group, line and the waves. The cloud with a vertically development fall into the two principal. The categories columbus and cumulonimbus. The columbus cloud are the dense, dome shape and have a flat base. And they may be grow to become a columbus. They consist of vertically development depending upon the force of vertically currents below the clouds as well as upon to the amount of the latent heat of condensations elaborate into the cloud as. they form to absorb the directly when a cumulus cloud may be covered to the whole sky and have to the appearance of nimbus structure. There is a wall nimbus is a reflex nimbo applied to a cloud from which rain is falling. Is a derived from to the latent form violent rain. The next year, medium cloud. The medium cloud, this is cloud are formed at altitude between to the 2000 to the 6000 meters. And this group cloud is include alto columns as the alto stars. The next year, high cloud. And this cloud are formed above the altitude of 6000 meter and include circus, circuitous and circulus is seen in the figure. Here show the picture. The cloud types are grouped into family according to the height and form. There is the most important diagram here. Here different types of cloud on form the earth. There is an important diagram for the exam view.
The next here, precipitation. There is the most important fifth here, precipitation. The precipitation is defined as the water is a liquid or solid form falling to the earth. You know that precipitations here are defined. Water is a liquid or solid form is falling to the earth. It happens when to the continued condensations in the body of the air help the water droplet ice crystal to grow in a size and the weight that the air cannot be hold them, and as a result this result of falling on the ground under the force of gravity. This is important here. The happen when to the continuous condensation in the body of the air help to the water droplet or ice crystal to be grow in the size and a weight that the air cannot is hold them, and as a result this start to falling on the ground under to the force of gravity. And the next here, the form of precipitation form here, the precipitation fall on the earth is a various form of droplet of water, ice and fog, and the solid ice balls are all and at the time of droplet of the water and the hell together. The form that a precipitation take is a largely dependent is upon the method of the formation of temperature due to formation. The form of precipitation are follow. The first point here is important here, drizzles and rainfall. Drizzle in a fairly uniform precipitation is composed exclusively of the fine drops of water with a diameter less than 0.5 mm. Only when droplets of this size are widely spaced and called rain. The next here, snowfall. The snowfall here is important when the condensation takes place below the freezing point. The freezing point here minus 0 Celsius. The water vapor change into the tiny ice crystal, and these tiny ice crystals grow in a size and form a ice fall, which become a big and heavy and start falling on the ground. And this form of precipitation is called snowfall. You know that what is a snowfall here? The tiny ice crystal grow in a size and form a ice fall, which become a big and heavy and start falling on the ground. And this form of precipitation is called snowfall. Snowfall is very common in the western Himalaya and the mid and high of altitude of regional in a winter. That is important. And next year, sleet. Sleet is a frozen rain. Is a frozen rains formed when the rain before falling on the earth and pass through a cold layer of air and freezes. The result is the creation of solid particles of clear ice. It usually is a combination of small ice and balls and the rime. You know that the result is the creation of the solid particles of clear ice, and it is usually to combination of small ice balls and rimes. There is an important here. Next here, hail. The hail is a precipitation of small balls or pieces of the ice. Hailstone, where the diameter is ranging from 5 to 50 mm, falling either to separately or the agglomerated into the regular lamps. Hailstones are comprised of the series alternatives layer of transparent and translucent ice. There is an important point here. Some point is the most important. A falling down to the atmospheric moisture on the earth as a surface is called precipitation. What is the precipitation here? The falling down of the atmospheric moisture on the earth as a surface is called precipitation. And the next, the precipitation is the form of tiny droplet of water, and bigger water droplet are known as the drizzle and rainfall separately. The important here. And the next here, when the precipitation is in the form of big ice ball, it is called rainfall. It is important here. The next topic is the most important here, types of rainfall. There is important here. What is the types of rainfall here? The important be now when a mass of moisture air ascends to be high altitude, it is a cool down to the lower temperature. In doing so, it is attain a dew point which is a lead to be a condensations and precipitation. Thus, the cooling of the air occur mainly when to the it arise. And there is a three important way in which a mass of air can be forced to rise, and each of this way produce it is a oven characteristics precipitation or rainfall. There is important here. Thus, the cooling of air occur mainly when there arise, and there are a 3-point way in which a mass of air can be forced to rises, and each of these way of produce it is oven characteristics precipitation or rainfall. There is a main point here. The first point here is a convectional rainfall. The convectional rainfall here is important. Excuses the heatings of the earth as a surface in the tropical regions result in the vertical air currents. This current is left the warm moisture air to the higher strata of the atmosphere. When the temperature of such a humid air start falling below dew point is continuously, and clouds are formed, and these clouds cause a heavy rainfall which is associated with the lightnings and thunder. The lightning and the thunder is the most important here. This cloud is a case to heavy rainfall which is associated with the lightning and thunder. The types of rainfall is called conventional rainfall. It is a very common in equatorial region, and where it is a daily phenomenon in the after here. Here show the conventional rainfall. That is the most important here. The heated air surface of the earth as goes west to here, a warm moisture air rising and cooling and condensation, and the formation of the cloud. But sudden time descending cool air and replacing rising warm air. There is the most important diagram showing there here. The clear on your mind. The next here be orographical and relief rainfall. What is orographic and relief rainfall here? Orographical rainfall on the formed where air rise and cool because of a topographic barrier. When there is a temperature fall below dew point, clouds are formed, and these clouds causes to the whispered rain on the windward slopes of the mountain ranges, and this type of rain is called orographic rainfall. However, when this wind is across over to the mountain range and descend along there is a ward slopes, and they get a warm and cause a little rain. Region lining on their leeward side of mountain receiving title the rain is called rain shadows area. A famous example of the orographic rainfall is the Cherrapunji on the southern margin of the Khasi Hill and Meghalaya, India. That is the most important example. There is orographic rainfall here. A famous example of Cherrapunji on the southern margin of the Khasi Hill is a Meghalaya, India. There is the most important example for you. Here show the orographic rainfall. There is formation here. A 3-point here, air ascending, expanding and cooling. But moisture is latent is the wind, what side and mountain base here.
The heavier rain is fall, cloud development. And second here, the air descending, contracting, compressing, and the warming. This rain is a shadow area where is counting rainfall. A leaf water slide. There is the most important of here. Show the diagram. The next here, convergence or cyclonic rainfall. There is the most important here. Convergences are cyclonic rainfall. Convergence rainfall is produced where air currents converge to the and rise. In a tropical region where is the opposing air current have a comparable temperature, the lifting is a more or less vertical and is usually is accompanied by the convention. The convention is activities that frequently occur along the front where there is a temperature of the air masses. The concerns are the quite different. The mixing of the air along the front also is probably contribute to the condensation and therefore to their frontal rainfall. Where two large air masses of the different density and temperature meet, the warmer moisture air mass is left above there is a colder one. When this happens, the rising of warm air mass is condensed to form a cloud, which is causing to extensive downpour. And this rainfall is associated with the thunder and lightning. And this type of rainfall is called frontal rainfall. You know that the rainfall is associated with there is thunder and lightning, and this type of rainfall is called is a frontal rainfall. And this types of rainfall is associated with the both warm and cold front. It is a generally steady and may be persist for a whole day or even longer. Here show the diagram. Rainfall associated with the warm front. There is the most important diagram here. Warm sector, fog, warm front, polar air is a height of 900 km. 8 kilometers is arrive here. So columns and the inward trusses. And front rain is here. And warm front is also there. There is the most important diagram show the rainfall associated with the warm front. And second diagram is the rainfall associated with the cold front. There is important two diagram here. The here 500 kilometer, other side is a 4 kilometer, and there is a stories as air, warm air and cumulative bus and direction of frontal of movement and cold front. There is the most important diagram here, and there is a cyclonic rainfall also here. The next here is the most important here, distribution of the precipitation. There is the most important here, distribution of precipitation. The spectral distribution of the precipitation is not uniform all over the world. The average annual precipitation for the world as a wall in about 97.5 centimeter, but there is a land receive a lesser amount or rainfall than the ocean. You know that there is important here. The average annual precipitation for the world as a whole is about 97.5 centimeter, but the land receives a lesser amount of rainfall than to the oceans. The annual precipitation show the marked difference on the land, and different place of the earth as a surface receive a different amount of annual precipitation, and that to the different season. That is important here. The main feature of the distribution of the precipitation can be explained with the help of the global pressure and the wind belt, distribution of the land and water body, and that is the nature of the relief features. Before arising at any conclusion regarding there is a questions for the regional and seasonal variation, let us first see the regional and seasonal distribution pattern of the precipitation. The first of all here, regional variation. The regional variation is the most important here. The regional variation on the base of the average amount of the annual precipitation, we can recognize the following precipitation region in the world. That is important here. The first point is the most important, region of the heavy precipitation. The regional which is receive about 200 centimeter of annual precipitation are included in the category, and this region include to the equatorial coastal area of tropical zone and west coastal zone of the temperate zone. There is important point here. The second point is the most important here. Regions of the moderate precipitation. The regions which receive 100 to 200 centimeter annual precipitation are included in this category. And this region lies adjacent to the regions of heavy precipitation. Eastern coastal region of the subtropical zone and coastal regions of the warm temperate zone are included in this category. That is important here. And third point, region of the less precipitation. Regions of the less precipitation here. This category included region which have received precipitation between 50 to 100 centimeters. And this region lies in the interior part of the tropical zone and west interior part of the temperate zone. That is important here. The next is the fourth point. Regions of scanty precipitation. The area lying in the rain, shadow, leavewards, side of mountain range, the interior part of the continents. The western meridian of the continent is along tropics and high altitudes receive a precipitation less than 50 centimeters. And this region include tropical, temperate and cold desert of the world. There is a important here. Here show the distribution of precipitation is the most important here on the world. Here the only is a white is less than 25, but has a line is a 25 to 50, and the dark line there is a 25 to 50 and 50 to the 100, and the next here 100 to 200, and the more than the 100 is the black. There is the most important distribution here. Now let us carefully study that a map showing the annual average precipitation and distribution of the world in order to be flowing conclusion. The first conclusion, precipitation is the greatest in the equatorial region and decreasing to about to the pole. And second here, precipitation is the heaviest in the coastal regions and decrease or to about to the interior of the continent. And third here, eastern coastal area of tropical land and the western coastal area of temperate land receive heavy precipitation including equatorial region. The next year, precipitation is very heavy on the windward side of the highland and where is dry condition is prevail on the leeward side. And the fifth point here, coastal area adjacent to be called current are less than the coastal areas near to the warm currents. Is important here. The warmest region of tropical land is a polar region, receive a scanty rainfall. The main reason began to that is a astralize become dry winds and the polar winds are cold and dry. That is important here. And the next here, seasonal variation. The seasonal variation is the most important here. The regional variation in the distribution of the precipitation in different parts of the world are based on average annual precipitation, which do not give us any correct picture of the nature of precipitation, especially of these regions where seasonal fluctuations in the amount of precipitation is very common. For example, arid, semi-arid and sub-humid region. Therefore, it is important to study of seasonal variation of the precipitation in the world. The fact related to there is a flowing, there is the most important here. The first point is important here. The equatorial region and the western part of temperate land receive a precipitation throughout the year. The former receive a conventional types of rain, while the latter get a cyclonic orographic type through the western lies. And second point is important here. About 2% land areas of the world receive a precipitation only in a winter. You know that? There is important here. About 2% land area of the world receive a precipitation only of winter time. And this includes the Mediterranean region of the world and the Mandels coastal of India. Due to seasonal grief, shift is a pressure and the planetary wind system. And this region is a Mediterranean do not get a precipitation in summer as they come under subtropically high pressure belt and trade winds which is become a dry while the reaching their two western meridian of continents. The next point here, the remaining part of the world receive a precipitation only in the summer. 2% is here, but other is a percent is the remaining part of the world receives a precipitation only to the summertime. That is important here. About 2% land area world receive a precipitation only for the winter, but other is percentage here. Remaining but is percentage here, or receive of summertime. It's make us clear that the most part of the world experience is a marked seasonal variation in the precipitation, and seasonal distribution of precipitation here provides an idea of the judges its effectiveness. For example, the scanty precipitation during to the short growing season in the high altitude is more effective than that of heavy precipitation in the lower altitude. Like view precipitation in the form of dew, fog and mist is a some part like a central India and Kalahari's desert has a perishable effect on the standing crop and natural vegetation. That is important here. The next here, see the factor affecting to rainfall distribution. There is the most important point here. The factors affecting rainfall distribution. The moisture supply to the atmosphere is the main factor is determining the amount of rainfall in any region. Equatorial and the rest of the tropical region have a highest evaporation and hence highest supply of the moisture. The coastal area has more moisture than the interior part of the continents. Frozen regions have a very low evaporation and has a very scanty precipitation. There is the most important here factor affecting the rainfall distribution here. The next year, wind direction in the battle of the trade and westerlies wind is very important. Winds blowing from sea to the land causing to rainfall. Land varying winds are dry. The wind blowing from the high to the lower altitude will get heated and give no rain, while those is blowing from lower to the higher altitudes will get a cooled and the cause of rainfall. Subtropical desert have a very little rainfall because they have a offshore wind. There is an important point here. And the next here, ocean currents. The ocean current is a warm wind are associated with the warm moisture winds which cause a rainfall. Cold current have a cold dry winds and hence no rainfall. The next point is the presence of mountain across the direction of wind cases of more rainfall on the windward side and create rain shadow on the landward side. And fifth point here is also important. Pressure belts are closely related with the wind direction and rainfall. The area of low pressure attract to the rain, wherein to the wind, while the area of high pressure do not. This is important here. The most important point here in the box, the distribution of precipitation in different parts of the world, showing to the mark regional and seasonal variation. The mark of regional and seasonal variation. The factors affecting rainfall distribution are moisture supply, wind direction, ocean current, presence of mountain and pressure belt. That is the most important point here.